All right, so here's part 2 of problem 347, finding the top k elements. We know that we can solve this problem by sorting the hash map of all the elements by their frequencies, and then choosing the top k elements from that sort. The problem is that the time complexity of that approach is bounded by the sort itself, which would therefore be O of n log n. We can do better. If we were to use a bucket sort approach, we would be able to reduce the time complexity down to O of n. But the problem is this: well, what is a bucket sort? So we're going to answer this question in this video, and then we're going to use our understanding of bucket sort to write a more efficient solution. So what is bucket sort? Well, essentially bucket sort works by placing each number into a predefined bucket or bin. What's great about this algorithm is that since the buckets are predefined, we don't have to rearrange our numbers as we sort them. We can go through our data in linear time as the numbers are placed in their respective buckets. Doing so means that the core part of our algorithm, excluding any extra work that might be in some sort of inner sort, will be O of n. Let's see this idea in action. We first convert our data into a hash map as before, but this time we have bins that will represent the possible frequencies each of our numbers could have. 1 gets sorted into bin 3 because there's 3 of them, 2 gets sorted into bin 2, and 3 gets sorted into bin 1. Now, the numbers are sorted by frequency in reverse order, so we simply need to append our answer with k elements from the bins. Here's another example. Larger numbers don't affect how the algorithm works. In this case, the number 12 goes into bin 1, along with 8 and 1. 2 goes into bin 2, while 4 will go into bin 3. If we would like the top 2 elements, we will return 2 and 4. Let's write this up. We will start by creating a counter object of nums, and then we will create buckets that represent frequencies going from 1 to n. Then, going through our counter, we will append the bucket represented by count with its num key. Our result is initialized, and then for each bucket in reverse order, we loop through the length of the bucket and append k numbers to our result. Once we have k numbers, we can then return our answer list. The time complexity of this algorithm will be O of n. Counting frequencies, creating buckets, assigning numbers to buckets, and traversing the buckets are all operations that are in linear time in the worst case. The space complexity is O of n because of the list of buckets and the counter object, each of which contain n elements. As you can see, we were able to vastly improve our solution. We also learned about a sorting algorithm that can help us whenever we need to sort objects by bin ranges. There will be other problems that we will use that will have bucket sort, so check back for them soon. See you next time.